You've probably had your blood tested at least once. A nurse pricks your finger. A drop lands on a strip. Seconds later, a letter appears. A or B, A, B or O. You know it. You forget about it by lunch. But the real answer to where that letter came from is far stranger than a hospital form. It is not a random label. It is a fossil. A fossil written in liquid, carried inside you, passed down from ancestors who never once heard the word blood type and yet fought wordlessly to give you the one you have. Start with the obvious question. Why does blood even come in types at all? Your heart doesn't care. It pumps whatever fills it. Your veins don't sort red cells by letter before they flow. So why does your immune system treat one stranger's blood as an invader and another's as harmless? The answer sits on the surface of your red blood cells. Literally on the surface. Tiny molecular flags, called antigens, stick out from each cell like flags on a ship. Type A cells fly the A flag. Type B cells fly the B flag. Type AB cells fly both. Type O cells fly neither. Your immune system was trained early in life to recognize its own flags as friendly and any unfamiliar flag as a threat. Mix the wrong bloods together and the body doesn't ask questions. It attacks. That system has a name. The ABO blood group. And it has a discoverer, a real one, a man named Karl Landsteiner, an Austrian physician working in Vienna at the turn of the 20th century. Landsteiner noticed something doctors before him had ignored, or maybe just accepted as normal chaos. Mixing certain people's blood together caused it to clump. Mixing others did not. He mapped out why. In 1901, he sorted human blood into groups for the first time in medical history. It seems almost too simple now. But before Landsteiner, transfusions were a gamble with a coin flip built into every patient's veins. His discovery didn't just explain a mystery. It saved more lives than almost any single finding in the history of medicine. But Landsteiner only explained the mechanism. He explained how blood types work. He never fully explained why they exist in the first place. Why would evolution bother building 4 different systems of red flags into a single species? Wouldn't one universal type have been simpler? Safer? Easier to share in an emergency? Here is where the story stops being about hospitals and starts being about survival on an ancient, disease-choked planet. Blood type is not cosmetic. It is a battlefield report. Every letter on your test result marks a war your ancestors fought against something microscopic, something that wanted to kill them before they could pass on their genes. And in that war, different flags meant different chances of survival, depending on where you were born and what was trying to infect you. Take malaria. For most of human history, in much of Africa, Asia, and the Mediterranean, malaria was one of the deadliest forces on Earth. It didn't care about your name or your tribe. It only cared about getting inside your red blood cells and multiplying. Researchers studying the Duffy antigen system, closely tied to red blood cell surface markers, found something remarkable. Certain surface variations made it dramatically harder for a specific malaria parasite, Plasmodium vivax, to latch onto a cell at all. Populations in parts of West Africa carry a red blood cell variant that essentially locks the parasite out. Not by chance. By generations of brutal natural selection. Every person whose blood cells happened to lack the right entry point for that parasite had an edge. They survived malaria seasons that killed their neighbors. They had children. Those children inherited the same locked door. Multiply that advantage across thousands of years, across thousands of outbreaks, and you don't get a curiosity. You get an entire population shaped around a doorway that a parasite can't open. Now take a different thread entirely. Cholera. A bacterial disease, Vibrio cholerae, that spreads through contaminated water and can kill a healthy adult within hours through catastrophic dehydration. Researchers studying cholera outbreaks, including work referenced in immunology literature following the disease's history across the Ganges Delta and Bengal region, found a disturbing pattern. People with blood type O were more likely to develop the disease's most severe, most lethal form. Meanwhile, non-O blood types offered some measure of relative protection. Now flip that same logic around to a different disease entirely. Smallpox. Some studies looking at historical outbreak data have suggested type A individuals may have faced higher smallpox mortality than type O individuals. No single blood type is a universal shield. Each one is a trade-off. Protection against one enemy. Vulnerability to another. Evolution doesn't hand out a perfect blood type. It hands out a gamble, tuned by whichever disease happened to be killing people in a specific place at a specific time. There's also the Rh factor, the plus or minus sign attached to every letter, a separate marker layered on top of the ABO system. Most people never ask what it actually means. It refers to another surface protein first identified through research on rhesus monkeys in the 1940s, and it carries its own quiet evolutionary story. Rh-negative blood is rare globally, common in only a small percentage of most populations, yet it appears at noticeably higher frequency in parts of Europe, particularly among Basque populations in northern Spain and southern France. Geneticists have long been fascinated by this cluster. Some hypothesize it reflects a population that stayed relatively isolated for thousands of years, preserving a genetic signature that got diluted elsewhere through migration and mixing. Isolation, in this case, didn't erase evolutionary history. It froze a piece of it in place, plus sign and all. This is the part that reframes everything. You did not get your blood type because it was the best one. You got it because somewhere back through your bloodline, in some specific region, against some specific outbreak, it was the type that happened to keep an ancestor alive long enough to have children. Your blood type is not a fixed trait handed out like eye color for aesthetics. It is a survival scar. A signature left behind by a war you never saw, fought entirely without your permission, resolved before you were even a possibility. And this war is older than modern humans. Far older. In 2008, a team led by paleogeneticist Carl Laloisifox extracted and analyzed ABO gene sequences from Neanderthal remains. The results were startling. Neanderthals, a separate human lineage that diverged from our own ancestors hundreds of thousands of years ago, appear to have carried blood type O variants strikingly similar to modern humans. Think about what that means. Long before Homo sapiens existed as a distinct species, before your specific ancestors had even evolved, the ABO blood system was already active in a hominin lineage. This was not a modern human invention. It was inherited from something deep in the shared root of the human family tree, a genetic system so ancient it predates our species and outlived an entire branch of humanity that no longer walks the earth. That single fact should stop you for a second. When you check a box on a medical form, BAB, or oh, you are checking a box that connects you to Neanderthals, to malaria epidemics in the Sahel, to cholera outbreaks along ancient river deltas, to smallpox scars on skeletons dug out of medieval graveyards. None of that history is visible on the form, but it's there, encoded, silent, waiting in every red cell in your body. Here's another layer most people never think about. Blood type distribution is not even across the globe. Type O dominates in parts of South America and among many indigenous populations. Type B shows up more frequently across parts of Central Asia and the Indian subcontinent. Type A appears at higher rates in parts of Western Europe and Japan. This isn't random noise. Population geneticists studying these distributions have connected them to regional disease pressures stretching back thousands of years. Different corners of the world face different killers. Different killers favor different flags. And so different populations ended up, generation after generation, quietly reweighted toward whichever blood type gave them the best odds against whatever was circulating locally. It gets stranger still. Blood type doesn't only interact with infectious disease. Some research has linked blood type to clotting tendencies, with type O individuals generally showing somewhat lower rates of certain clotting-related conditions compared to nonotypes. Lower clotting risk sounds purely beneficial until you realize clotting itself evolved for a reason. In a world without modern medicine, a fast, efficient clot was often the difference between surviving a wound from a hunt, a fall, or a fight, and bleeding out on the ground. So even within the advantage of resisting one disease, there could be a hidden cost elsewhere in the system. Nothing in this story is a free win. Every blood type is a bundle of trade-offs, optimized not for you personally, but for the population your ancestors lived and died within. There's a modern research thread that connects even further into the gut itself. Some studies looking at the interaction between blood type antigens and the gastric bacterium Helicobacter pylori, a major driver of stomach ulcers and stomach cancer risk, have found that people with type O blood may bind the bacterium's attachment proteins more readily than people with other types. In some populations, this has been linked to differences in ulcer risk. Once again, no clean winner emerges. The same type O blood that may have offered protection against one historical killer shows up in a different context, tied to vulnerability against another. Nature rarely builds a flawless design. It builds a compromise shaped by whatever pressure happened to be strongest at the time and the place for that specific population. And then there's the myth you have probably heard, even if you didn't know where it came from. In parts of East Asia, particularly Japan and South Korea, blood type is popularly treated the way Western culture treats astrology. Type A people are said to be careful and anxious. Type B people are said to be creative and unpredictable. Type O people are said to be confident leaders. None of this has any real scientific backing. Peer-reviewed research has consistently failed to find meaningful links between ABO blood type and personality traits. But the popularity of the belief itself tells you something true, even if the belief is false. Humans have always sensed that blood type means something deeper than a hospital label. They just filled in the wrong explanation. The real explanation was never about who you are. It was always about who survived to become your ancestor. Which brings up the uncomfortable, fascinating question. Is your blood type still fighting a war that no longer exists? Malaria has been eliminated in huge parts of the world where it once devastated populations. Smallpox has been fully eradicated as a human disease, the only one in history to earn that title. Cholera, while still present in some regions, is nowhere near the scale of its historical outbreaks in areas with modern sanitation. And yet the blood types shaped by those exact diseases are still here, still being passed down, still splitting people into A, B, AB, and O on hospital intake forms, long after the evolutionary pressure that built them has faded into medical history books. You are, quite literally, walking around with defensive architecture built for battles that, in many parts of the world, are already over. That's the paradox sitting quietly inside your veins. Evolution is slow. Diseases can vanish in a single generation, wiped out by vaccines or sanitation or medicine. But the genetic changes built to survive those diseases don't disappear on the same timeline. They linger. They get passed forward, mostly invisible, occasionally relevant, sometimes completely irrelevant, in a body living in a world nothing like the one that built it. Consider it from another angle. Somewhere right now, a person with a certain blood type is living in a city with clean water, refrigerated food, antibiotics on every pharmacy shelf, and a healthcare system that can treat almost anything that once killed their ancestors outright. The disease pressure that shaped their blood type generations ago simply doesn't exist in their daily life anymore. Their body is still built, cell by cell, for a threat that has already been defeated. Meanwhile, in a different part of the world, someone with a different blood type still lives somewhere malaria remains a genuine seasonal danger, where the ancient trade-off encoded in their red blood cells is still, quietly, doing real work. Same species. Same underlying genetic system. Two completely different relationships with a war that built it, running in parallel, right now on the same planet. There's a modern twist worth sitting with, too. During major surgeries, natural disasters, and mass casualty events, hospitals still sort blood by these same ancient categories before anyone can receive a transfusion. Type O negative, sometimes called the universal donor, becomes the most demanded blood type in every large-scale emergency. Blood banks issue public appeals for it constantly. Emergency rooms track their own negative supply like a countdown clock. In other words, the exact genetic trait shaped by ancient epidemics has become the modern trait that saves the most lives in an emergency room, thousands of years, and an entirely different kind of crisis later. Ancient survival math is still running quietly in the background of every hospital in the world. Go back further to a moment when this ancient system directly shaped a modern war. During the Second World War, military medics faced a brutal logistical problem. Wounded soldiers were dying not just from injuries, but from blood loss on battlefields where matching a donor to a recipient quickly enough was nearly impossible. Physician Charles Drew, building on the blood-typing groundwork laid by Landsteiner decades earlier, helped pioneer large-scale blood banking and plasma storage systems that could be shipped to the front lines. His work saved an almost unimaginable number of lives. And it only worked because the ABO system had already been mapped, decades before, letter by letter, type by type. An ancient survival code, first written into human DNA by prehistoric disease outbreaks, ended up becoming the backbone of 20th century battlefield medicine. The war your ancestors fought against invisible pathogens quietly armed the medics fighting a completely different kind of war thousands of years later. Even today, the logistics haven't changed as much as you'd think. Type O negative remains scarce precisely because it is rare in the population, a genetic minority pattern shaped by the same regional disease pressures discussed earlier. Blood banks in large cities constantly monitor their own negative reserves the way a city monitors its water supply during a drought, because a single mass casualty event can drain a regional supply within hours. Meanwhile, type AB plasma, universally compatible in the opposite direction, gets stockpiled for different emergencies entirely. None of this modern infrastructure was designed around convenience. It was built around the stubborn ancient reality that your cells still carry flags raised by battles fought long before hospitals existed. Think about what that really means the next time an emergency broadcast asks for blood donations. That request is not just modern logistics. It's an echo, a direct line back to a Paleolithic community somewhere, fighting off an outbreak with nothing but immune systems and time, unknowingly deciding, through who lived and who didn't, which letter would end up in your veins. So the next time a nurse tells you your blood type, don't just file it away as a piece of hospital paperwork. Picture where it actually came from. Picture a Neanderthal carrying a version of the same gene, tens of thousands of years before a single word of language existed to describe it. Picture a village in ancient West Africa where one small red blood cell variation quietly decided who lived through a malaria season and who didn't. Picture cholera moving through a crowded settlement near an ancient river, and blood type quietly tilting the odds of who walked away. You're not just carrying blood. You're carrying the final scoreboard of wars fought long before you existed, wars you never had to fight yourself because your ancestors already won them for you, one outbreak at a time. That letter on your medical chart isn't random. It's a message sent across thousands of generations, still arriving in your bloodstream today. You've probably had your blood tested at least once. Now you know the letter it gave back wasn't just information. It was inheritance. It was history. It was survival, still circulating, still alive, still running through you right now.